1.6, we are going to talk about step functions. And we are going to also graph some piecewise function. So what a step function really does is, imagine you have a linear equation. So let's say our linear equation is y equals x. Well, our linear equation y equals x, if I draw this really quickly, it kind of goes like this, right? It just goes like that. But I'm going to change these markers here. This is 1, and this is 1, and this is 2, and this is 2, and this is 3, and this is 3. The slope is still the same. What a step function does is, let's say we want whole dollar amounts. We don't want decimals or fractions as possible answers. So say if you're working with coins or something, we can't have a fraction of a coin. So we want a whole dollar amount. So what a step function is, it simplifies the equation into a step. So it starts off here, so say y equals x. At y equals x at the whole integer, right? So at 0, 0, at 0, x is 0. So here what you do is it can equal 0, and then we worry about the whole integer. At 1, it can equal 1. At 2, it can equal 2, and so on. So you see the pattern like so. But then we only want the whole integer number. So then we extend it, and then from there we do an open circle. Because it doesn't equal that, it equals it, we step up to the next whole integer. So here, open circle. Here, open circle, and so on, like that. So if we got the number, let's say we got the number 5.6. Well, we don't want 5.6 in the step function. At 5.6, we go down the whole number. We want actually 5. We want 5 in the function. Or let's say we have a negative number and we have negative 1.3. Well, negative 1.3 is somewhere here. So we don't want negative 1. We don't go up, we go down. And going down to negative 1.3 is negative 2. So you got to be careful when we are dealing with negatives in a step function, pulling out the values of a step function. Let's graph some piecewise equations. So let's say if we have f of x equals 9 plus x, and x squared plus 3 when x is less than or equal to 3 and x is greater than 3. So let's think about this. So from negative infinity to 3, it is a linear equation of a slope of 1 and intersects at 9. So from here, and I'll just say this is 3 right here. So the slope of 1, and it intersects at 9. So this is 1, 2, 3, 4, 5, 6, 7. We'll assume this is 9. Let's scale this down. Let's assume this is going in 3s. So let's say this is 3, this is 6, and this is 9. Okay, so this would be our intercept. Our slope is 1, but remember this is vastly different scaled. So here, this would be negative 3, this would be negative 6. So it would actually be way like that. This isn't to scale because we changed the scale, okay? And then for the next part, it says, okay, for the future part, greater than 3, it should equal x squared. Well, at 3, first of all, let's put in 3. 3 plus 9 is 11. No, it's not 11. It's 12. Oh my goodness. 12 So here would be the point right there. It'd be 12 because this is 12. Let's put in 3 squared plus 9. 3 squared is 9 plus 3. That's also 12. So they actually touch at the same place. So here's the back half, and then the other half is a parabola going up. So it will kind of look like, well, let's look what the parabola going up, if I plug in the next value, since we're going up by 1 increments on the x-axis. So if I plug in 4 squared is 16. 4 squared plus 3, that gives us 16 plus 3, which is 19. So here, this is 12, this is 15, this is 18. So it goes pretty like here. So it's a really steep parabola. So that is what that graph looks like. It's a little funny, but that is what the graph looks like. Let's try a more difficult one. Maybe not difficult, but let's say time consuming. So let's say h of x equals 4 minus x squared. X is less than or equal to -2, 6 plus x, and -2 is and x is between -2 and 0, x squared plus 1, and x is greater than or equal to 0, like that. Okay, so let's unbox this. At -infinity to -2, it is a upside down parabola. This indicates here, I know this is upside down parabola. Let's put in the value for -2. So at -2, 4 minus 4, well, that is a big old 0. 4 minus 4 is 0. So at -2, it's 0. So at -2, so let's do this. Let's make this -2. So this would be 0, like so. It is less than that. So it is less than that, so it doesn't equal it, because we have that, it doesn't have an equal sign. So we don't want to close 0. We want an open circle. And then it is an upside down parabola. So let's find the next value over. So the next value back is -3. So let's do -3. So if I plug in -3, that is 9. So 4 minus 9 is going to be the one back. So 4 minus 9 is -5. So here, if this here, we go down to 5. 1, 2, 3, 4, 5. So down here, and this is upside down parabola. So here, from here to here, it kind of curves down like that. Like that. Let's go, what about the next one? Okay, so let's, from -2, so the middle problem, so from -2, it can equal -2. So -2, 6 plus -2 is 4, right? 6 plus -2 is 4. So here at -2, it can equal 4. So go up 1, 2, 3, 4. So here it will be a closed dot because it can equal it. It is the slope of 1. That is a linear equation, slope of 1. I can graph that pretty easily. And it goes all the way from that, from -2 to 0. But it doesn't equal at 0. So we're going to have an open circle like so. And now let's go to 0. 0 squared plus 1, the final equation. 0 squared plus 1, well, we got 1. So that means at 0, it can equal 1. So I'm going to put a closed circle at 1. That is an x squared plus 1. I know what that looks like. It is a parabola, the second half of parabola that curves up. I don't even have to put in points. I know it looks like this. So that is the piecewise graph of that set of equations. If you want to check, right, you can put in 1. 1 squared plus 1 is 2, and right here that is 2. So we put it in just right for that parabola.